Okay, so today, guys, I want to show you how to test a hard drive to see if it's good. We use this software a lot. It's called Victoria. And with Victoria, you can do all kinds of things. Of course, one of the main things you can do, of course, is see the model of the drive, what firmware version it's running, what serial number is, disk size, LBAs. It's a 3 terabyte drive, one that I've highlighted here. Cylinders, head, and sectors. Of course, SMART is enabled, error log, self-test. There's all kinds of different things you can do with it. In a little while, I'm going to take you over and show you how to test one on the test bench. We have 3 or 4 drives plugged into the test bench we need to test. And typically we test not new drives, but drives that have been in machines for a while running, to see if we want to reinstall an operating system on it or potentially purchase a new drive. If you have drives that have been used in a server for a year or two, you may want to test them to make sure that they're still solid and that they're still reading and writing data the way they're supposed to. It's like with this one, for example. I'm going to show you a little bit about it here before I actually take you over the test bench. It's 3 terabyte. You pull the SMART data, click on the SMART tab, go to Get SMART, and it shows you the raw read error rate. Right now that's a 0. Spin up time. This is the amount of time this drive has been running, 10,941. Number of spin up times, the number of times the drive is actually spun up. Reallocated sector count is 0. It's good. It's what you always want to see. Seek error rate is 0. Power on time. Again, this is quite a bit of time. The health here on the side shows, of course, the 5 green bars shows, it's good. And as these start going down from green to yellow, they'll go all the way down to red. So if you start seeing a lot of G-shock, and I'll show you some of those whenever we get over to the test bench, you'll start seeing that red coming up. If you start seeing really high reallocated sector counts, I really don't like to see anything other than 0. If you start 1, 2, not that big of a deal, but you start getting into 5, 10, 20 reallocated sectors, and where the sector itself has gone bad and the OS has taken that data off the drive, off that sector, and moved it to another sector, then you're looking at a problem. So what this is doing is it's looking at the surface of the disk, and it's going to read every block, right? So, and it's going to look at a response time. It's the one test we always run is the read test to make sure that it can actually read the data that's on the drive. So this is milliseconds. So this is 3 milliseconds, 12 milliseconds, 30 milliseconds, 120, and 360. We want to see low numbers, right? So whenever we're scanning a drive, and this will go through when I hit start, it'll go through and scan the entire drive, every LBA. And it'll give me a response time from all these sectors, or all these blocks. And it'll tell me, what the response time was. And this is really good for telling whether the drive is about to fail. So if you start seeing a lot of 120s, a lot of 360s, and especially greater than 0 or errors, then that drive is potentially going to fail very quickly. Especially if you start seeing some of these. So back every data as soon as possible and start moving to a different drive. So I'm going to start this, and you guys can see on this Western Digital, it's 3 terabyte. It pretty much stays at 25 milliseconds. So I'm only at 0.1%, but the drive is a storage drive. I'm not actually running the operating system off of it. The operating system is on the NVMe drive over here. It's the Samsung NVMe. Of course, I'm testing now, so I can't change drives. But the operating system, when it's is running on the NVMe drive, and the 3 terabyte drive is for storage. We typically don't run Victoria on a machine that is running from the operating system. So if the operating system is installed on the hard drive, you don't want to scan it with Victoria, because you're going to get inaccurate read times. Because if the operating system is reading and writing to the hard drive as Victoria is scanning and testing the hard drive, then you're going to have issues. Typically we do this in a live environment, and I'll take you over in a minute and show you how to test with a live environment. and run Victoria inside a live version of Windows 10. Go ahead and stop this, and you see we've run 24,522,751 LBA logical block addresses. So we're only 0.4%, but we're really good. We have 11,975 connections for 25 millisecond. So nothing down here. Of course, the longer I scan this drive, the more of these I'm going to see, I'm sure. I don't think I've ever scanned this drive. It's fairly new. So, like I say, this is a precursor to failure. If you start seeing a lot of 1 second and 3 second, of course these changed, right? They were 360, but if you start seeing a lot of 1 second and 3 second time, you're gonna be looking at a drive that's going to fail. So I'll catch up again when we get to the test bench. Alright, so as you guys can see, this is Hiren's boot CD, PE, Windows 10. We just booted up the test bench from a live DVD. Of course, you can see we have network. Go over some of the tools that we have inside Hiren's. Windows recovery, Windows setup, hardware info, those kinds of things. Mainly what we want to do today is check hard drives. We have 4 hard drives plugged in, and you guys can see some of them are already mounted. USB drive is where the software we're going to use is living. We use a piece of software called Victoria. Copy that to the desktop, and then we're going to extract it. So here's the software, Victoria.exe. You can download it from several different places on the internet. We usually download it from Major Geeks. I just keep it on this thumb drive, and anytime we have to check hard drives, always run Victoria. So you can run it multiple times. As you can see, it comes up and shows drive ATA passport, and shows the model number, firmware number, serial number, capacities, 250 gig drive. Cylinders, heads, and sectors, smarts enabled, error log, self-test. Gives you a lot of information about the drives. Of course, if you want to go through and select a different drive, you select a different drive over here. Of course, here's my thumb drive, 16 gig. And one of the drives I have plugged in isn't showing up. I'm only showing 3, whereas I actually have 4 drives plugged in. So I think one of them has already physically failed. So I want to show you how to test this first one. This is a 250 gig Samsung. First thing we'll do is pull smart data. And of course the smart data will tell you all kinds of different things about the drive. The raw read error rate, raw value 17 on this one. Spin up times 2625. That's based on the amount of time that this thing has been on. Number of spin up times is 916. Reallocated sector count is pretty high. That's a 40. We don't want to see any reallocated sector count, but especially if it's a 40. Recalibration retries, max 99,999. Power cycle counts, this many times it's been powered off and on, it's 505. It's a pretty old drive, and these health over here on the side show you how healthy the drive actually is. So it'll start counting down from green, and then yellow, and then down to red. So when you start seeing red on here, then you know the drive is starting to fail. Right now we have 1 currently pending sector, which is not good. Of course, this will show you G-shock, the G-sensor shock counter, as this thing apparently has been thrown off a building. 54,171. We're going to go ahead and test it just to be on the safe side and see what it looks like. So you click on the test and repair, and then these are all the different sectors. So what it's showing you is all the sectors on the drive, and it's going to go through and it's going to scan them. It's going to do a read, and what this numbers here are showing you, 5, 20, 50, 200, 600, is the response time. This is the response time in milliseconds. So we have 5 milliseconds, 20 milliseconds, 50 milliseconds, 200, and 600. And then we have greater than 1 second. And then this will show errors. So if we have errors in the drive. So typically if we have 5, 20s, and even 50s, the drive is usually in pretty good shape. So as long as you don't have bad smart data showing you that the drive's starting to fail, and your numbers between 50 or between 5 and 50 are good, then the drive should be in good shape. So if you start getting a lot of 200s, start getting 600s, especially 600s, 600 millisecond response time for that sector, then you're looking at a drive what we call as pre-fail. So I'm going to start off a scan with this, and that will go through, and you can see we've already have a bunch of greens at the very front of the drive. We have 5. Now you can run this multiple times, so I could open up Victoria again. So we have 4 drives plugged in, but only 3 of them are showing up. So I can run Victoria again, it'll come up again, and then I can just pick another drive and go through the whole process. I typically don't like to do this unless I'm working with faster hard drives, because I've seen where if you're running this multiple times, checking multiple drives at the same time, starting one test and repair has a tendency to affect another. So typically don't do more than 2. So this one has a load and unload cycle count of 277,262. You can see here on the health, the little dot is red. G-Shock counter is 2. So this one has been bumped a few times while it was been on. Uncorrectable ECCs 4, which is not good. But we have no reallocated sector count, so our sector count, reallocated sector count, is low. Of course, shows head flying hours, total sectors right, total LBA read. I really like this software. So we'll go ahead and test repair this one. And again, this one will show you how many milliseconds to be able to go back and read each block of data. So click on scan, and it'll go through and start scanning. So whenever these finish, you see this one's 2.3%, this one's 0.2%. It'll just show 100%. It'll stop, and you can just go through and count up and see how many different high millisecond blocks you have. Like I say, the more 200 you have, the more 600 you have. You might want to start looking at buying a new hard drive and moving all of your data over. Now I've seen some drives, really doesn't depend on the age. Mean time before failure on a hard drive is typically 5 years. But I've seen some drives that are 10 years old that are perfect. 5, 20, and 50 millisecond blocks, and they work just fine. So that's that.